Hello, this is Britt Caswell with another example video. In today's video, I'm covering example 2 from section 4-3 in the SavvasRealize Algebra 2 textbook. The goal of this example is to simplify a rational expression. So there are actually a couple of questions here for this example when it starts out. It says, what is the simplified form of the rational expression? So we're going to simplify this. And then we also need to identify the domain for which the identity between the two expressions is valid. Alright, this is just like what I did in example 1. So I created an equivalent expression in example 1 and then simplified it, not realizing that later on I need to simplify it. But then our domain, right, we identify our restrictions. So we're going to go just through that again here with example 2. So remember, our first step with these is to start by factoring stuff. Now notice that my numerator here, it has the x term second, and then my constant is first, and so that's kind of backwards. So what I'm actually going to do is I'm going to start by factoring out a -1 so that I could change the signs on those and turn it around the right way. And I know that might seem like a goofy step to do here at the beginning, or it might be something that's hard to see, but just recognize, like, if your terms seem backwards, like your higher exponents are the ones at the end and they're negative, just multiply by -1 and it kind of sets things going the correct direction. Alright, so now we're going to factor our numerator and our denominator, so don't forget our -1 sitting out there. So this is a difference of squares, right? So I can separate a plus and a minus into the parentheses, and then take the square root of the first term and the last term in order to fill in the other spaces. So there's where I have used my difference of squares formula. Now down here, right, I'm going to start my parentheses with an x each because I have the x squared. I'm going to drop down my plus. And then to get a -10 here, I have to have opposite signs. So this one's going to be a minus. And then I ask myself, what multiplies to make 10 that subtracts to make 3? That's 5 and 2. So at this point in time, I have found the equivalent expression. So now I need to define my domain. All right, let me change colors so you guys can see that it's a different bit of text I'm doing here. So my domain, all right, I'm going to use set notation for this. It's all the values of x where x is a real number. Sometimes you might see it like this. You might see a funny e. That means is included in the set of real numbers. Sometimes you'll see an equal sign there. You might just have somebody write x is a real number, like in words. But I'm trying to show you as many forms of this type of notation. But we do have to restrict what values we can have for x. So I'm going to say where x is not. So if I were to set x plus 5 equal to 0, I'd have a restriction at -5. And right here I'd have a restriction at 2. So there is another way that you might notate that. Yeah. And just remember, those values came from setting the denominator of the fraction equal to 0. The numerator of the fraction, if you set that equal to 0, that just tells you where the graph crosses the x-axis. So there's our domain, which was the second question. So now we need to go through and simplify our expression here. All right, so if I look in the numerator and denominator, I have an x minus 2 on each one. And that's the only thing that I have in common there. So my expression turns into -1 times x plus 2 over x plus 5. And if your book is picky and requests you to distribute, you can distribute this out and get -x minus 2 over x plus 5. That's another valid answer. So both of these are completely acceptable. It just depends on whatever your I don't know, standardized test or your textbook tell you to do. All right, these ones are asking us to do the same thing. Kind of ugly, but we got this. Up here at the top, that's a quick factor thing, right? If you recognize it, that's a perfect square trinomial. So this is x plus 1 times x plus 1. I like to leave them separated like that, but you could write it as x plus 1 squared. But since we're in the process of canceling stuff out, and I'm probably going to cancel one of those out, I like to keep them separate personally because I find that it makes it less confusing when I'm crossing stuff out. Now down here, I notice I have an x in everything, so I'm actually going to factor an x out. And so when I do that, it just drops the powers here. So this turns into x squared minus 2x minus 3. And then I'm just going to double bubble it. So I have an x and an x. My first sign's a negative. To get a negative 3, I have to have an opposite sign. And what multiplies to 3, that subtracts to make 2. That's 3 and 1. So here's our equivalent expression. Now we have to state our domain, right? Alright, so our domain is all real numbers except x equals 0, x equals 3, and x equals negative 1. Alright, so that's another way that you might see the domain written out. So they'll say it in words, right? Alright, so now to simplify the expression, I'm looking for what's in the numerator and the denominator that I could cancel out. I see an x plus 1 on each of those. And that's it. Those are the only things that match. I like to think of it as a game of Go Fish or something. So my final expression, I have x plus 1 over x times x minus 3. And again, if your book is picky, you could distribute if you need to. So x squared minus 3x is another one that works as well. Okay. So now on this one, you guys might be a little uncomfortable with because there's 4 terms in the numerator and you might be uncomfortable factoring it. But check out your coefficients here. Do you see how I have the coefficient 1, 4, 1, 4? And I have positive, positive, negative, negative. So this is a sign here that you're going to factor by grouping, if you can identify that pattern. So in factoring by grouping, what I'm going to do is I'm going to separate these 2 sets of terms with 2 sets of parentheses with a plus between them, and then I'm going to factor out the GCF for each term. So my GCF for x cubed and 4x squared is x squared, and that will leave me with x plus 4. And in this one, do you see how it already has almost an x plus 4? But the signs are backwards, right? Because it's negative x minus 4. So that means that the GCF I need to factor out to flip the signs here would be a negative 1. Don't panic about this bottom part yet. We'll get to factoring that in a moment. So once I've done that for my factoring by grouping, I'm going to go ahead and take the stuff that I factored out, my GCFs, and those are going to go in their own set of parentheses at the beginning of the expression. Okay, so I'm going to have x squared minus 1 together like that. And then the expression that we have copies of, the x plus 4, is going to come out like that. So we've started to break this down. Now because I don't have a linear term here, this x squared minus 1, I'm actually going to factor that further. Alright, that's a difference of squares. And it factors in the form x plus 1, x minus 1. and then down here I'm actually going to go ahead and factor the denominator now. So I have an x and an x. I know I have a plus, and to get a minus I need opposite signs. And what subtracts to make 4? What multiplies to make 4 that subtracts to make 3? That's 4 and 1. Alright, so now we're going to go ahead and find our equivalent our like similar terms that we can pull out. Alright, so I have an x minus 1 in the numerator and denominator, and I have an x plus 4 in the numerator and denominator. So when I cancel all that stuff out, all that I'm left with is an x plus 1. And it's technically over 1, but I don't need to write over 1, because when you divide by 1, it's the same expression. So this is my final solution. Now when I go to talk about the domain, I need to make sure that the domain that I'm basing it off of is before I cancel all my stuff out. Because here the x plus 1 has no restriction to the domain, but the original problem does. There's values for x that I could plug into the denominator that set the denominator equal to 0. Alright, so my domain, I need to show the restriction of -4 and +1. Another way you might see that domain is they might actually break it up like this. It's kind of ugly notation. They might put union symbols in there, which is cool. So that's another way they'll show it, is in that interval notation. Alrighty, so there we have it. That is how to simplify the rational expressions and to still identify their domains. Until next time.